Hello friends, today we are going to discuss another problem on truss. You can see the diagram in front of you and the loading is as shown in the figure. We are supposed to find the forces in all members. We will solve this problem in a big way. We will use method of joints as well as method of sections while solving this problem. Uh, Please note that the length of any particular part is not given, so we will assume that the length DC is 1 and we can proceed with that understanding. And the first step, as we know, we have been discussing this, is to find all the lengths. So let us try to find all the lengths first. Let me take this length over here as 1 unit. Let me draw a dotted line here. You can see that if this angle is 30, this angle is 90, this angle will be 60. So if total length is 1, then this particular small length over here will be 0.5. That is side opposite. You can use cos 30, tan 30 and all, and you can find the lengths. This particular perpendicular length will be 0.289. You can do the math, and this particular length will be 0.577. Since it is symmetrical, this length also will be 0.577. You can see this and this angle is 30 degree. So if this DC is 1 unit, AC also will be 1 unit. Now you can see this angle is 60 degree. Over here, this angle is 120. So this angle also will be 60. That makes this triangle as equilateral triangle. So all the lengths will be 0.577. This will be 0.577. This also will be 0.577. Let us look at this particular triangle now. This angle is 30 degree, and since these two lines are parallel, over here you can see that this particular angle will also be 30 degree, because this is 30. If you draw a perpendicular, this will be 90. So this entire angle will be 60 degree. Out of which this angle will be 30 degree. So now what is left is to find this length. Now you can look at this particular triangle. If this angle is 60 and this is 30, this total angle is 120 degree. So this angle will be 60. This angle will be 120, 30 degree. This angle will be 30 degree. This is 90. So this angle will be 60 degree. Again, you can do the math and you can find out this particular length. This particular length turns out to be 0.333. This particular length is 0.333, and so this length, since both these angles are 30, AB also will be 0.333. So this particular length will be 0.33. This particular length also will be 0.33. So all the lengths we have computed here, assuming that this length to be total length to be 1. This is 0.577. This is 0.288 or 289. This is also 0.577, 0.577, 0.577, 0.33. You can do the math. It's very easy, and you can find all the lengths. Now once we find all the lengths in the step 1, our step 2 is to find the support reactions. One reaction will be at D and the other reactions will be at C. Please note there is no horizontal force here. So at D there will be no horizontal reaction. There will be only two vertical reactions. One is VD and one is VC. The sum of VD and VC will be 20 plus 50, that is 70 kilonewton. So let me write over here VD plus Vc will be equal to 70 kilonewton. Now we can take moments about D or moments about C, and you can get the value of any one of the two reactions. So let me take moments about D. There will be how many forces? One will be 20, other will be 50, and the last will be reaction Vc over here. So look at the momentum of 20 kilonewton. The momentum of 20 kilonewton about point D will be 0.5. Momentum of Vc, which is the vertical reaction, about point D will be 1. Now what is left to be found out is the momentum, this particular momentum. We want to find length, this particular length over here. Now from here to here the length is 1 unit, and if you compute the length from here to here, then this is 1 unit, this whole thing is 1 unit, this angle is 30, side opposite to 30 degree will be half the hypotenuse. So from here to here the length will be 0.5, and so the total length from D to this particular point will be 1.5 units. It will be 1.5 units. So we have got these three momentums. Let me erase it all. So we have a situation. Let me redraw. There is one reaction over here, Vd. So one reaction over here, Vc. There is a 20 kilonewton force coming up. This distance is 0.5. From here to here the distance is 1, and there is one 50 kilonewton force coming up. This total distance is 1.5. So let me take moments about D. With a convention of clockwise positive, and what do we get here is 20 into 0.5, that is clockwise, minus Vc into 1. You can see this is anti-clockwise, and 50 into 1.5 is clockwise. Is equal to 0, and that gives me the value of Vc as 50 into 1.5, 75, 75 plus 10, that is 85. So Vc is 85. We also know Vd plus Vc is 70, and that gives me Vc as minus 15, that is 15 in the downward direction. So we have Vd plus Vc at 70, and that gives me Vc as 85, and Vd as minus 15. Vd is minus 15 and Vc is 70. Vc is 85. So we have obtained the support reactions, and now what comes is to use the method of sections, method of joints to find forces in various members. So let us quickly apply the method of joints to section to point D, and let us see what we get. I am drawing joint D here. At particular joint D, we have got a support reaction which we have just computed, Vd, and Vd was minus 15, that is 15 downwards. We have this force. Let us assume this force to be tensile. So we have F dc here, and we have another force which again we are going to assume to be tensile, that is FDE, and this angle over here is 30 degree. So it's obvious if you do sigma Fy equal to 0, FDE will be resolved into two components. This will be resolved into two components. One is cos 30 and a vertical component as sin 30. So it is the vertical component which will be equal to 15. So I get FDE sin 30 equal to 15, and that gives me FDE as 30 kilonewton. Now let us do sigma Fx equal to 0. The cosine component and DC will be, both of them are to the right. So let me write here FDE cos 30 plus FDC equal to 0. If you put FD as 30 cos 30 plus DC equal to 0, please do the math and you will get the value of FDC as minus 30 into cos 30. How much you are getting? You will get minus 25.9. The negative sign indicates that DC is a compressive force, that is, the direction is not to the right, the direction is to the left. So please note that the DC turns out to be a compressive force. So that is joint D. Now let us proceed further to joint E. There is a please note that we have already computed DE, and DE as tensile 30 kilonewton. So there will be a 30 kilonewton tensile force here in the downward direction, which we have already computed. Let us see various angles here. This angle will be 30 degree. This will be also 30. You can refer the original diagram and you will see that you can see very easily these angles can be seen. This angle will be 60 degree. This angle also will be 30 degree. So again let us do sigma Fx and sigma Fy, and you will get the answers. So I am going to write the two equations here. One is sigma Fx equal to 0 with right side positive. So what I have is FEF cos 30, that is to the right, plus FEC cos 30 is also to the right, minus this 30 cos 30 to the left, equal to 0. That is one equation. If you use sigma Fy, that is in the vertical direction, you will have second equation, FEF sin 30 in the upward direction, minus FEC sin 30, that is in the downward direction, minus 20 minus this is 30 sin 30, equal to 0 If you solve these two equations, you will get the value of EF and EC. So please solve that, and you will get EF as 50 and you will get EC as minus 20. Please make sure to do these calculations and you will get the answer.